because it's not very intuitive. So remember, we're reflecting things across lines, and I feel like I should give a quick lesson about lines in order to move on here. This is stuff that we should have seen before, and hopefully it's like, oh yeah, I remember. If it's not, um, probably want to see me sometime, in the future for office hours or afternoon hours about it. So, quick lesson about lines. The usual way we like to see lines, there's a couple different ways, but we usually like them in what's called slope-intercept form, and this should look really familiar. Y equals mx plus b, and this is slope-intercept form because this is the slope, and this is the intercept. Right, so if I had y equals 3x plus 1, then that 3 is the slope, and that 1 is the, more specifically, the y-intercept. So back, maybe on this example, this is not the right equation. I don't know why this showed up, but the actual equation of this line should be y equals negative x plus 1. The slope is negative 1 and visible 1, right, over 1 down 1. And the y-intercept is 1, meaning we start on the y-axis at 1, right? And then to graph lines that were in slope-intercept, one very common thing we did is we used this mnemonic that should also sound familiar, rise over run. And what rise over run is saying, how do I figure out the slope? Slope is usually if this line is given to you. The slope is just whatever number is attached to the x here. So, and then we use rise over run for the slope to help graph. So, and what I mean by rise is the change in y, and run is the change in x. Right? And the way to think about that, rise is up, right? So up or down should be y. Run, if you're running on a graph, you'd be going left and right. So that's where that comes from. And what that tells us is that if we have, let's say we have the line y equals 3 halves x plus 4. That rise over run, what this tells me, so if I had that line, what this y-intercept is 4 tells me is that I'm starting at y is 4 up here, and then what this 3 halves tells me, the slope of 3 halves, rise over run tells me the slope. Rise meaning 3, rise on top, 3 on top. That would mean I would go up 1, 2, 3, and then run on the bottom is 2, right? Run on the bottom, rise over run, meaning I go in the x direction, 1, 2, right? And that's where my next point would be. Or I could go down 3, right? 1, 2, 3, and then I'd go over 1, 2. And I should get a line with a slope of 3 halves. And then I always just like to go up or down with the 3, right? So I can choose to go up 3 or down 3, and then I determine if I need to go left or right based on if this is positive or not. If we remember positive slope, which 3 halves is positive slope means that you're kind of running uphill. You can think of the slope guy. If he's walking uphill from left to right, that's positive, right? A negative slope, if this was negative 3 halves, I would have had to go up 3. So maybe I'll do this. Maybe if this was negative 3 halves, I'd have to go up 1, 2, 3, but then over 1, 2 from this point, right? Because then it would be going this way. And my slope would be negative, right? Slope guy's going downhill means negative. Very quick rundown of equation of a line, slope, rise over run, stuff that's hopefully, again, hopefully should be like, oh yeah, that's kind of there in my brain in a file somewhere. I just need to pull it out a little bit. So that's like graphing a line. Now, one thing that we want to notice is that every time we did these reflections, right? If this was here and this was here and the other ones, all of these points that make lines here, there's something special about all the lines that are made, right? If I do this one, would be here. There's something special. That one's not that great. Hold on. So true. There we go. There's something special about all of these lines, and it's that they're a fancy word. Like when we're reflecting a point, right? So here's the point we reflected right here and here. The lines that connect that to their original point all have something in common, and they're a fancy word that we should have heard before. And probably should know what it means, but perpendicular. And what does perpendicular mean? That just means it makes a right angle, right? They make 90 degrees with each other. And that's what's special about all these lines and reflections is that when you reflect them across, you should be, the line that connects them should be perpendicular to the one, this one's not drawn the best, but it should be perpendicular to the one you already have, right? And so we're going to use that when we get more complicated ones. Like these ones, it's easy to mirror over because you just count how many spaces, right? These ones you have to count the diagonal spaces, not that bad. But then when we get one like this, where it's like the diagonal spaces are, right, here's 1, 2, but then it's like not right in the middle, right? So I can't, it's hard to count diagonals. And that's because of the slope that this line has. It's not, it's not nice like 1 or -1 or just a flat line or a vertical line. And there's two things. Again, this is probably more so in the back of the brain, but the big thing here is that if you have a line, let's use this example again. Maybe we had 3 halves x plus 4, and I wanted to make a line that was perpendicular to this line, right? So here's this line, the 3 halves x plus 4. It's in red, but blue here. It's going to be a little confusing, but that's okay. To make a line that's perpendicular or 90 degrees, right? To make that line, there's two things you need to do, and you need to do this. You need to look at the slope, and you need to do two things. You need to make it opposite, and then you need to take its reciprocal. So what do those two things mean? So the slope here is 3 halves. Opposite means switch the signs. So since this is positive, I'm going to make it negative. If it was negative, I would make it positive. Reciprocal then means flip it. That's all it means. And so then this would be the slope of a perpendicular line, -2/3 x. And then it doesn't really matter what the intercept is. But that's all we need to know to solve these problems. So let's do this example. So our slope is something, it's not 1 or -1. It's kind of gross. Our slope is -2/3. And so we want to find lines that are perpendicular, so we need to find the opposite reciprocal. So if the opposite would be switch the sign, so +2/3, and then reciprocal would be flip the fraction, so 3 halves. And so this is our new slope that we need to go off of. And I'm going to use the rise over run in order to reflect this across this line. So this is the slope 3 halves. So from this point, I'm going to go rise up 3, 1, 2, 3, and then to the right 2, so it's positive, right? Because if I were to draw a line through that point and that point, I'd get a positive slope. So I want to go up 3 and to the right 2. So I go up 1, 2, 3, right 1, 2. And you'll see when I do that one time, I'm right on the line. So if I do that one more time, 1, 2, 3, 1, 2. That should be reflected across the line. Let's do the same thing here. 1, 2, 3, 1, 2. Right on the line. So if I do that again, 1, 2, 3, 1, 2. That should be that point. Again, I'm doing the rise over run. Rise meaning wise, up and down, right? Run meaning left and right. So rise 3. So 1, 2, 3. Run 2. 1, 2. Rise 3. 1, 2, 3. Run 2. 1, 2. And so since I did that twice for that point, I'm going to do it twice now. So I'm on the line right now. I did it twice to get there, so I'm going to do it twice again. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And then this, do my best to connect these on the tablet. That would be my new shape after being reflected. So the whole gist is find your slope, find the line that's perpendicular, right? So what this is saying is if I go from this, right, that's a reflection. That's a reflection. And these lines are perpendicular. So these lines that connect these have the slope 3/2, right? Up 1, 2, 3 over 1, 2. Up 1, 2, 3 over 1, 2. We can kind of see that these little lines that connect these have this new slope of 3/2, which was the whole idea. So slope, take its opposite reciprocal, and then to each of those points do the rise over run the same amount of times on the other side as you did to get to the middle. So one more example, one like this. Reflect the line, or reflect the figure of the line y equals negative 3x minus 1. Well, okay, our slope is negative 3. Opposite would be 3. But what's its reciprocal? Well, remember I said the reciprocal is flipping the fraction, but we don't have a fraction here. But it's a good thing that we can make whole numbers like this a fraction if we want. And how do we do that? Remember, if we put it over 1, then we've made it a fraction. So the reciprocal of 3 is 1/3, right? I flip the fraction. All right, now I'm going to do rise over run again. And it's another positive slope, so when I rise 1, I'm going to go over or run 3. 1, 2, 3, right? Run 3. Rise over run. 1 over 3. So up 1 to the right, 1, 2, 3. Up 1 to the right, 1. And then some change, right? Or wait, hold on, where are we at? Negative slope, opposite, switch it. Yep. So we want positive 1/3. So rise 1, 1, 2, 3. Up 1, 1. And then we're kind of like halfway. So 2, 3. Up 1, 1, 2. And that should be a slope there. So up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Up 1 over 1. And then we're kind of in some stuff. So 2, 3. And then it should be 3 away, right? So up 1, up 1 over 1, 2, 3. Up 1 over 1, 2. There we go. Because it should be the same diagonal distance away here. Up 1 over 3. Up 1 over, up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. So I did that 3 times, so I need to go up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. And we notice that we get the same looking shape, right? And it's as if you imagine, if you like put your hand on the screen, right, and then you flip it the other way, it makes sense that this kind of like pointed out one here is now facing on the inside, right? Because you're flipping it, you're mirroring it. And a good way to tell if you've kind of flipped it, right, is it should be the same size, right? It should look like the same size. So um, that is the only other example I have. Um, but again, the whole idea is find out your slope, find its opposite reciprocal, so that's your new slope, right? And the idea is here, right, if I were to connect those lines, my drawing is not perfect, but this should be a right angle, right? And that's kind of the whole trick.